Okay, we're looking at the related rate problems. We have, let's see, the radius of r, radius r I'm calling, of a circle is increasing at a rate of 3 centimeters per second. What is the rate of change of the area when r is equal to 3 centimeters? Find the rate, and then we got another part to the problem here. It says find the rate of change of the radius when the rate of change of the area, which I'm denoting as dA over dt, is equal to 2 pi. And I guess that should be centimeters squared there, but I don't know why I didn't put that in there. And A is equal to pi centimeters squared. So they're giving us the area. We want to find the rate of change of the radius, dr over dt. Okay, that's the second part. So let's go back to the first part here, and that's what we want to work on. So we want to find the rate of change of the area. That would be dA over dt when r is equal to 3 centimeters. Well, first thing we need to start off with the formula for finding the area. So we have a relationship of area and radius here, and everybody should know this one. We should know that the area of a circle is equal to pi r squared. So now what we're going to do is we're going to take the derivative of this, and the derivative of a is 1. Then remember, we write dA over dt is equal to, we take the derivative of pi r squared, so we take the 2, bring it out front, rewrite pi, subtracting 1, remember, from r, and then we tack on the dr over dt. And so now what we're going to do is just go ahead and plug in everything that they gave us. Well, they said dr over dt was 3 and r is 6, and there we go. And don't forget, we need to tack our units on to the end of our final problem, since that's what we started with. So we end up with 36 pi centimeters squared per second, and whatever that is. But this is the exact value, right? You might want to approximate that to get an idea of actually what that number is. All right, well, let's look at the second part to that problem. Of course, I'm going to have to come back and read it so I can remember what it was. Find the rate of change of the radius. So we're looking for dr over dt when the rate of change of the area is dA over dt, which is 2 pi. So the rate of change of the radius, right? Rate of change of the radius, dr over dt, that's what we need to find. And of course, they give us some more information here. A is equal to pi centimeters squared. Of course, we're going to need to know that. So once again, we start with A is equal to pi r squared, and we're going to take the derivative of this, just like we did in the previous problem. But what we're going to have to do now is we're going to have to find r, okay? Because remember, we're looking for dr over dt, and they gave us dA over dt, but what we don't have is r, so we're going to need to take this guy up here and solve for r. They did give us the area was pi, remember, centimeters squared. And so we're going to set that equal to the pi r squared and then just solve for r. Well, r obviously here is 1. Okay, so now we can plug everything in. So we have dA over dt, which was 2 pi, and then we plugged 1 in for r, and remember dr over dt was 1 centimeter per second, or no, that's actually what we're solving for. I forgot what I was doing. Okay, so anyway, we just get to this point here, and then I've got it written out as we solve for dr over dt, which ends up being 1 centimeter per second. And don't worry about this down here, that's the next problem.